Next, we see what options we have when we need to represent the distributions. Firstly, we've got histograms. Histograms are one of the best ways to represent frequency distributions. One difference between a regular frequency distribution and a histogram is that histograms are able to handle unequal bin sizes as well. Okay? So if any of these bin sizes, these that you see over here are uniform bin sizes, 0 to 10, 10 to 20, there is an equal bracket gap between these two. But that may not be necessarily the case. If you look closely, that this difference between 10 and 20 is split between 2 bars. Okay? So the actual value would be over here, and this again 20 to 30 is split between 2 bars. So you see that this unequal bins distributed 10 bins and only a range of 80. So this unequal distribution is supported by histograms, while it is not possible in the regular frequency charts. So that's the greatest advantage of using frequency histograms instead of the frequency charts. The other thing that we can use is the density plots. As I just said, that these are the frequency charts, but the difference is that we find the area under the curve in order to find the density plots. So we can see what variance is occurring in given some one or the other variable. We can use heat maps. Heat maps again represent the intensity or the highest value. The highest concentration would be with the highest value in the heat map, and the smaller concentrations, the lesser compact, lesser crowded regions would have smaller values in the heat maps. Okay? So heat maps again tell you which areas are highly crowded and which areas are less crowded. We can use box plots, also known as box and whisker plots, and these again represents the distribution. We've got 3 different quadrants here, and we can find out how many data values lie in the first quarter, then in the second quarter, in the third quarter, so on and so forth. We can have some central and median value, and based on that, we can tell what the overall variance of the data that we have is. We'll conclude today's lecture with some of the tips for displaying data. First one is that 3D may not be a good idea in all cases. Okay? So 3D information in some cases may actually be misleading. So if you can perfectly represent the data in 2 dimensions, 2D, or flat regions, do not unnecessarily change it into 3D. Okay? We saw that in case of scatter plots as well, that 3D is actually more misleading. Then the second one is if you've got a lot of lines or a lot of variables, you should provide a legend or a key. Okay? Then use different symbols. You can have these smaller circles and larger circles. You can have these dotted lines or broken lines. You can have the consecutive lines. So you should have different symbols for each of the line you're using, each of the variable you're using. Then the color of the background graph and line should be clearly distinguishable. Okay, we saw a bad example where we use too much of yellow color, so don't do that. That would again mix things up so bad that you wouldn't be able to see what's going on in your actual visualization. In case you want to print your visualization, or it would be represented in some magazine, some other printed media, then color should not be the only distinguishing attribute. Okay? So if you've got something like this, if I print it, it would look exactly the same. So maybe I can have different lines in one of these and different shape in the other one, and then I'll be able to differentiate between them even when they are in the print medium. Keep graphs simple. Okay? The whole idea of graphs is to easily or quickly represent information. So do not unnecessarily add extra colors, 3D or pictures. That would complicate things and hence kill the actual purpose of your visualization. And always use meaningful titles and links. Okay. Do not make people guess what your data is representing. Instead, actually show them what it is. Then colors or choices of colors matter. If you look at this one, now this is again representing information on density of population. But if you represent the same information using these colors, now I can pretty clearly see that you can see that there are many regions that are more identifiable in this image than in the first image. Okay? So the choice of your scales, the choice of your colors can have a huge impact in the amount of information that you're eventually representing. So be very, very clear about that. These are some other examples, and you can see that these are surfaces of some objects. And while we're trying to ascertain the depth of these, we are using different color maps or heat maps over here. And if given bad choices for heat maps, there's very little information that you see. And in these cases, with proper colors, there is much better information that we can extract from these. So always be very clear about or which range of colors would you be applying in order to extract your heat maps. Visualizations can easily be done in Python. Some of the libraries that are available are Matplotlib, Pandas, Seaborn, Gplot, Altair, and for thematic maps, we can have Folium, Basemap, and other visualizations can be done with Bouquet. The best thing is that these are interactive plots, and then again, Plotly. Matplotlib is one of the basic libraries it has, and this is the base used by a lot of other libraries such as Seaborn as well.